All right, let's talk about AI because it's way, way more than just a cool app on your phone now, right? We're talking about a full blown industrial revolution. This isn't just about chatbots anymore, it's a massive shift, all powered by silicon. And it's pointing towards a future that feels like it's straight out of science fiction the singularity. So let's get into it. So here's the game plan for today. First, we're going to explore why AI is truly a new industrial revolution. Then we'll pop the hood and see the insane amount of power that makes it all tick. After that, we'll meet the current heavyweights, the AI titans of today, before we look over the horizon at what's next, things like humanoid robots and our quantum future. And finally, we'll tackle the really thorny but super important questions about how we govern all this. It's going to be quite a journey. Okay, let's dive right into our first big idea, AI's industrial revolution. And I'm not just being dramatic. We're talking about just another piece of tech here. We're talking about a fundamental rewrite of how whole industries work and how economies grow. And this quote just nails it. The Global Artificial Intelligence Report calls AI the new innovation engine. It's speeding everything up, from making healthcare diagnoses more accurate to making manufacturing lines way more efficient. At this point, using AI isn't just a neat advantage, it's becoming the ticket to the game if you want to stay competitive. And speaking of innovation, the tools we're using are just exploding with new capabilities. Actually, I have to show you something that is a perfect example of this creative leap. It's called Kling 2.6, audio from a company called Higgsfield. And get this, it generates video and expressive audio at the same time, in one single process. I mean, just think about what that unlocks. If you're a content creator making shorts or explainers like this one, boom, you've got instant synced voiceover. For advertisers, you can spin up video ads where the tone and the sound just perfectly match the message, and you can do it incredibly fast. Filmmakers, you can generate entire scenes with built-in atmosphere and voice. Even VFX artists can test out concepts with auto-generated ambience. Here, let me just show you. I'm on the Higgsfield AI website right now. I'll type in a prompt. A friendly host in a studio, enthusiastically explaining a complex topic. Now for the voice, I'll add clear, energetic, and engaging male voice. I click Generate, and Kling 2.6 creates the video, the voiceover, and even the background sounds all at once. The final result is completely coherent. This is a huge time saver for agencies and creative teams who deal with a lot of video and need a workflow they can count on. And here's the best part. You're going to want to hear this. Higgsfield is offering unlimited Kling 2.6 audio generations for everyone who subscribes to their ultimate plans by December 12th. Unlimited. And if you look at their pricing, Higgsfield has the lowest prices on the market right now. It's pretty obvious their whole mission is to be the most creator-friendly platform out there. You should definitely check it out at higgsfield.ai. So that's just a wild look at how AI is changing creative work. But all of this, from generating content to the large language models we talk to, relies on an incredible amount of computational power. So what exactly is fueling this powerful new engine? You know, every time you type a question into a chatbot and get an answer back in seconds, it feels like magic. But it's not. Behind that simple interface, there's a massive, power-hungry engine room. So now, let's pull back the curtain and deconstruct it.
To even begin to understand this, you need to know one key term, the FLOP. It stands for floating point operation per second. And the analogy on the slide is perfect. If AI is an engine, then flops are its horsepower. It's a pure measure of raw number-crunching muscle. And just look at the scale we're talking about. A gigaflop is 1 billion operations a second. A teraflop is 1 trillion. Normal data center stuff, like streaming a video, hangs out in that giga and teraflop range. But AI? Well, AI's playing a completely different sport. We're getting into petaflops and exaflops. We're talking about numbers with 15 or even 18 zeros after them. It's just mind-bending stuff.
So let's try to wrap our heads around this. Let's take a powerful traditional computer chip, like an Intel Xeon Gold. That thing can do about 100 gigaflops. That's 100 billion operations every single second. Sounds incredibly fast, right? Well, just wait. Let's see what happens when we bring in the hardware that's actually built for AI. And here is the leap. Wow. An NVIDIA A100, which is a GPU designed specifically for AI, delivers 312 teraflops, not giga, teraflops. That's over 3,000 times more powerful than that high-end CPU we just looked at. We've just jumped from billions of operations per second to trillions. This right here, this is why GPUs are the absolute heart of the AI revolution. But it doesn't even stop there. The next generation, the NVIDIA H100, can hit a peak of 1 petaflop. That's a quadrillion operations a second, one followed by 15 zeros. This is the staggering, almost unbelievable power needed to train the massive AI models that are changing our world.
So who exactly is wielding all of this petaflop power? Well, it's time to meet the AI titans. You can think of these models as competitors in a global arena, each one with its own unique training, architecture, and special skills.
First up, the one that really brought conversational AI to the masses, ChatGPT from OpenAI. Its latest versions, like GPT-4o, are what we call multimodal, which is a fancy way of saying you can throw pretty much anything at it, text, images, even live video and audio, and it just gets it. Next up is Claude from Anthropic. Now, Claude has built a really strong reputation for being a deep thinker. It's especially good at complex reasoning and is a fantastic coding assistant. It even has this unique extended thinking mode that lets it work through really tough, multi-step problems more effectively than a lot of its rivals. Then we have Google's powerhouse, Gemini. Its key advantage is that it was built from the ground up to be natively multimodal, which means it was designed from the start to seamlessly handle a mix of inputs. And with a massive 1 million token context window and deep integration into everything Google, like search and docs, they're making Gemini pretty much unavoidable. But don't count out the challengers. A startup out of Paris called Mistral AI is making huge waves, and they're doing it by focusing on high-performance models that are also open source. Their goal is to basically democratize access to powerful AI, making these tools more efficient and available to everyone, which is a pretty serious challenge to the closed-off models from the big tech companies. Okay, so we've seen the power and the players of today. But what about tomorrow? This is where things start to feel a lot more like science fiction, and the lines start to blur with reality. We're talking about artificial general intelligence and humanoid robots. This image really captures the whole feeling of it, doesn't it? This is about the quest for artificial general intelligence, or AGI. This is the holy grail, the pursuit of an AI that could actually surpass human-level thinking. It's not about being good at just one thing, but about understanding, learning, and applying intelligence across almost any domain you can imagine. And believe it or not, we're already seeing the physical bodies for these AGI concepts. Humanoid robots are no longer just experiments in a lab. Tesla's Optimus is actually working in its factories. The famous Atlas robot from Boston Dynamics is being used for logistics. Figure AI is working with BMW, and another company, Unitree, has robots working in hotels. The robots are here, and they are learning fast. So if humanoid robots feel like they're just around the corner, let's take one more giant leap, way out to the distant horizon: quantum computing. And this isn't just a faster computer. It is a fundamentally different way of processing information, and it has the potential to revolutionize AI all over again. Now, let's be clear, we are not there yet. This timeline lays out the roadmap pretty well. We are currently in the experimental NISQ era. It's noisy and not super reliable. The next decade is all about moving to systems that are fault-tolerant, and it probably won't be until after 2035 that we see mature, commercial-scale quantum computers that can really deliver on those transformative promises. And what's wild is that the race to build a practical quantum computer is being fought on all these different fronts. You have companies pursuing completely different physical methods, from the superconducting circuits that IBM and Google use to things like ion traps or even photonic computing. It's a testament to just how hard this problem is and how incredibly valuable the solution will be. So all of this brings us to our final and maybe our most important section. With all this mind-blowing power, from petaflop GPUs to autonomous robots, we have arrived at the ultimate crossroads of power and responsibility. We have to figure out how to navigate the governance gauntlet. And the challenges are just immense. Data privacy is a constant battle. Cybersecurity has basically become an AI versus AI arms race. The environmental cost is staggering. These AI data centers are eating up a huge and growing slice of the world's electricity. And maybe most importantly, we have to ensure these systems are used ethically and transparently, especially in really sensitive areas like law enforcement and public policy. And so that leaves us with this final critical question. As this technology's power grows and grows and grows, who is responsible for making sure we use it wisely? It can't just be the developers or the corporations or the governments. The question of who is responsible for wielding this power is a question for all of us, and it's one we need to start answering right now. Thanks for watching.